needed to, spin the rotor so fast to lift, and on top of it,
flown to the International Space Station with Crew. The space shuttle flew to the International Space Station, and now the Crew Dragon is taking human beings to the International Space Station. So we've partnered with SpaceX in the Commercial Crew Program. They design, build, and operate these vehicles that transport us to the International Space Station so that we can contribute to the amazing work that we're doing up there.
Yeah, it's a commercial space vehicle to the International Space Station. We will be working on the international...
It's extremely difficult to fly at Mars because the atmosphere is so thin compared to Earth.
It has to be fully autonomous from the time it takes off to the time it lands.
So the first and foremost challenge is to make a vehicle that's 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's
50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority
is the zero gravity going to be like, how that might challenge our expectations for what we can get done. So you really feel like you've become a resident of space, a resident of zero-G. And you start to feel like you're getting an idea of how this works. Every day is a long series of problem solving. You got to figure out where to put your pencil, where to put your drink if you have it. So maybe 10,000 times a day you're solving little problems like this. And when that becomes fluid, then you really feel like you can be efficient and get a lot of work done. And there's a lot of work to get done on the space station right now.
We spend a lot of our time training in Dragon.
so much images, but I'm sure we'll return a few.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height.
Time on the space station is spent, one, keeping the space station healthy. It's been up there for 20 years. There's a lot of systems that need maintenance and upgrades and operators there to keep them working well, but we also do some incredible science.
What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
International cooperation for exploration. It's not for survival, it's not for competition in the marketplace, it is for just exploration.
I think we're now about...
Indicate chute deployed. The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
OVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about 1 kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Curiosity has driven nearly 7 miles to its current location at Mount Sharp and found evidence of past conditions suitable for microbial life. To mark the anniversary, NASA is unveiling 2 new online tools that will bring the Mars experience to a new generation of explorers. Mars Trek is a free web-based application that uses more than 40 years of Mars exploration data to provide high-quality imagery of the planet's features. Experience Curiosity is a 3D simulation program that also uses real data to take viewers along with Curiosity during the rover's expeditions on the Martian surface. Since NASA's robotic explorers became the first to study the red planet, advances in technology have enabled Mars exploration missions to continue making important scientific discoveries and pave the way for humans to reach Mars in the 2030s.
Did you know sound works differently on Mars than it does on Earth? Mars' atmosphere is cold, making sound travel more slowly. Thin, making sounds quieter. And mostly carbon dioxide, making sound more muffled. Microphones that record sounds on Mars. This is the actual audio of a Martian dust devil. And this is a recording of the Ingenuity helicopter in flight. This is the sound of the Perseverance rover driving on its metal wheels. For more Sounds of Mars.